I'm gonna continue from the previous video about the limit of the function of two variables. The thing that we are studying here is called limit along the curves. So the question look like you have to find the limit, but you see that we're gonna have some extra condition for this one. I'm gonna highlight it, y equal to x here. So you see that the question look like the one that we had in the previous video. However, for this one, it's gonna be some extra condition on y equal to x. And the way to solve this one turned out to be kind of different. So if we like to find limit x, y go to 0, 0, you may think that, hey, it's going to be 0 over 0 again, and we cannot simplify anything much further because we not be able to factor this guy, right? However, this one is about the limit along the curve. The way to solve this one is going to be, you're going to put y equal to x in terms of y. So you see that it's going to be, you're going to use the condition y equal to x, and you see 1y here. Okay, so you see 1y here. And this one, you're going to change this term to x square over x square plus x square. And you see that the thing that you use the yellow condition, and you see that everything turned out to be x without y anymore. So the limit turned out to be just the limit for x go to 0. So you see the difference between the limit that we had before and the limit that we have right now is going to be, you are having limit x go to 0, and it's going to be the function in one variable. And you see that this guy can be simplified to x squared over 2x squared. And this one turned out to be, you'll be able to get rid of x squared and x squared. So this guy is 1/2. Okay. So you basically get this answer for this limit. You see, this one is different. Okay, and you don't need to factor anything. You're gonna just plug in the condition, the yellow guy, into the given condition, and you're gonna be able to solve this one quite quickly. Okay, let's try the second one. You have limit xy go to 0, 0 of 2x squared y over x plus y squared on x equal to y squared. Again, you have the yellow condition on x equal to y squared, and you see two x's here that you're gonna change by using the condition x equal to y squared. So this one is going to be 2 times y square square. Okay, so this guy is the yellow guy, multiplied with y. Okay, and you have this thing over x, which is y square plus y square. Okay, so you see that you allow to combine, okay, the bottom guy. So it's going to be, you see the top guy is going to be 2y to the 4th, so it's going to be y to the 5th, and the bottom guy is going to be 2y squared. And you, let me highlight 2y squared for you to see easier. Okay, so that my bottom guy, and you see that this guy is going to be limit y go to 0 because you have no x left, so it's going to be just y. And you gonna get rid of y squared and y to the 5th, so this one is going to be y to the 3rd, and you allow to cross out 2. So this one will be limit y go to 0 of y to the 3rd, and it's going to be 0 to the 3rd, and it's going to be equal to 0. Okay, so the third one, you have limit xy go to 0, 0 on y equal to negative x. So for this one, the condition is y equal to negative x. And you're gonna just plug in y equal to negative x into 2y here. So you have y on top and y on the bottom. So in this case, it's going to be limit, and you have x squared, and y to the third is going to be negative x to the third. Okay, so this one is the yellow guy, and you gonna have, it's gonna be over x to the 6 plus negative x to the 6. Okay, and so for this one, it's gonna be limit x go to 0. Okay, because you have no y left, so it's gonna be just limit x go to 0, and you have negative x to the 5th over, and this guy, when you sum them, okay, so when you sum these two terms, so this one turned out to be x to the 6 plus x to the 6, so this will become 2x to the 6, and this guy is going to be limit x go to 0, and you can get rid of x to the 5th and x to the 6th, so it would be negative 1 over 2x, and this will become 1 over 0. Okay, so it's going to turn out to be 1 over 0. So we're going to conclude in this case that the limit does not exist. We're not going to determine infinity or negative infinity, so it's different story. So we're going to just say does not exist. That's enough for the conclusion. Okay, so this limit along the curve y equal to negative x in this case does not exist. So that will be our conclusion. Okay, so for the next one, we have the function fxy equal to xy over x squared plus y squared when xy not equal to 0, 0. We like to find the limit xy go to 0, 0 of this function fxy on the falling curve. So this will give you the yellow curve. Okay, so on the x-axis, on the line y equal to x, and on the line y equal to 2x. Okay, so I'm gonna do the x-axis and y equal to x for you. So for this one, you're gonna find limit x, y go to 0, 0. Okay, and we're gonna say on x-axis, and the x-axis in this case is the line y equal to 0. Okay, so we have x-axis is the line y equal to 0, so this will be our curve C1, and the function given by x, y over x squared plus y squared. So you have y equal to 0, you're gonna put y equal to 0 for this y and this y. So this will become x times 0 over x squared plus 0 squared. Okay, and you're gonna have limit x go to 0. One thing that this one is a little bit tricky. I just like you to see the thing that I will circle. So I will circle this guy. So the circle that I have is x times 0 over x squared plus 0 squared. Inside this circle, this one become 0 because on top is 0, on the bottom is x squared. Okay, and this guy will become 0 without taking any x. Okay, so I'm not gonna let you see limit. So I'm gonna just let you see x times 0 over x squared plus 0 squared. This guy will be equal to 0 over x squared, and this one will become 0 before taking the limit. Okay, so it's before taking the limit. So what does it mean? It means that on the other line, you're gonna just write limit of the constant 0. Okay, so it is 0 before you are taking the limit, and it's going to be limit x go to 0 of 0, and this one will become 0. Okay, so this one will become 0. So that will be our limit on C1. Okay, it's not 0 over 0. Okay, some of you think that, hey, if you not consider this one, you just take limit, you get 0 over 0, which is the indeterminate form. However, this one is not equal to an indeterminate form. It's going to be just 0 before taking the limit. Okay, so that is going to be the thing that kind of tricky to do. Okay, for the second one, let me just copy this one. Okay, so for this one, you're gonna have this limit and it's gonna be on y equal to x. Okay, so it's gonna be on y equal to x. You're gonna get limit xy go to 0, 0. Okay, so sorry, it's not limit xy go to 0, 0. It's gonna be, you're gonna plug in y equal to x. So it's gonna be x times x over x squared plus x squared. Okay, so it's gonna be x times x over x squared plus x squared. And this guy is gonna be limit x go to 0. Okay, so in this case, it's going to be, let me highlight y, okay, so that my y equal to x that I plug in, and you're going to have limit x go to 0, x times x is x squared plus x squared is 2x squared, and this one will become cancel. Okay, so this one will be equal to 1/2. Okay, so this one will be equal to 1/2. So you have the limit for xy over x squared plus y squared on y equal to x equal to 1/2. Okay, so this one will be 1/2. This one will be equal to 0. Okay, so two questions. I will leave number 3 for you to work on your own. Okay, I give you the solution during the recitation. So why did we study? Okay, why did we study the limit along curve? The thing that we are studying, the limit along C1 and C2 that we have for the previous example turned out to be useful in order to determine whether the limit at x0, y0 does not exist. So if you have the point, okay, let me call this guy x0, y0. Okay, so I'm gonna have to erase this one. It's not a, b. Okay, so it's gonna be x0, y0. Okay, so if you have the point x0, y0 as shown in the picture, and you are going to this point along many curves. So this one may be your C1, this one may be your C2, this one may be your C3, C4, blah, blah, blah. So you see that you can go to this point x0, y0 in many directions. If you compare with calculus 1, okay, so if you compare this guy with calculus 1, in calculus 1, you see the picture, okay? So the picture turned out to be a real number line, and you have a, and you have x go to a in this direction and in this direction, okay? So you have x go to a from the left, and you have x go to a from the right. Okay, so you have x go to a from the left side, and you're gonna have x go to a from the right side. Okay, so you have x go to a from the left, and you have x go to a from the right. This one is calculus 1. Okay, however, for calculus 2 that we are studying the function in several variables, or in this case in 2 variables, you see that we can go to the point x0, y0. Okay, so we can go to the point. So this one has coordinate x0, y0. Infinitely many directions. Okay, so you see that we can have, or we can approach the point x0, y0 infinitely many directions. And if you recall Cal 1, you have limit x go to a from the left of fx not equal to limit x go to a from the right of fx. You're gonna say that the limit x go to a of fx does not exist. Okay, so this is calculus 1. If you have left limit not equal to right limit, the limit turn out to be does not exist. However, for calculus 2, you can go to x0, y0 in infinitely many ways. So in this case, if you be able to show that you have two directions, C1 and C2, that the limit does not equal to the limit do not equal to each other. So in this case, you're gonna be able to conclude that. Okay, so let me just box this one. So if you be able to show that the limit x0 x go to on C1 and limit on C2 are not the same, so you be able to conclude that the limit does not exist in this case as well. Okay, so that is going to be used for showing that the limit xy go to x0, y0 of fxy turn out to be does not exist. So let's do this example. You see that you have the limit on C1 equal to 0 and the limit on C2 equal to 1/2. Okay, so for this one, it's going to be C1 and this guy is going to be C2. So you see that the limit on C1 and on C2 are different. Okay, so limit x, y go to 0, 0 on C1 of xy over x squared plus y squared does not equal to, let's try, I still have this guy, okay, on C2. Okay, so it's going to be on C2. So you have the limit on C1 equal to 0, limit on C2 equal to 1/2. Okay, so you have the green color and you have the blue color. Okay, so they are not the same, so they are different. So in this case, you're gonna say that limit xy go to 0, 0 of xy over x squared plus y squared does not exist. Okay, so that you have reached the conclusion that the limit does not exist and it's gonna turn out to be, okay, so it's gonna turn out to be our conclusion for the limit at the given point does not exist. Okay, so you have kind of left limit not equal to right limit. However, for this one, it's gonna turn out to be limit on the direction of C1 not equal to the limit on the direction of C2. Okay. So the way to show example 8 turned out to be, we like to show the falling limit does not exist. So the way that we're gonna do is gonna be, we're gonna find direction C1 and C2. Okay, so we're gonna find two direction. Okay, so we're gonna find two direction that we have different limits. Okay, so we're gonna find two directions that we have different limit. So for this one, okay, so for this one, you're gonna find limit xy go to 0, 0 of xy over x squared plus y squared. Let me, we already did this example. So it's gonna be, you use example 7, okay? Use example 7, so we not have to do anything for example 8. Okay, so it's gonna be, we already done this one. Let's try number 2. So we have limit xy go to 0, 0 of x to the fourth plus y square over x to the fourth minus y square. So for this one, you're gonna find two directions that you have different limit. So we're gonna just use the basic one, like on the x-axis and on the y-axis. Okay, so let's just try on x-axis and on y-axis. Okay, so basically it's gonna be just the direction that quite easy. Let me just try them out. So you see that, I'm gonna copy this one. Okay, so we have this limit. Let's do this one on the x-axis. Okay, so when you use on the x-axis, it's going to be limit on the x-axis mean that you have y equal to 0. So you get x to the fourth plus 0 square, x to the fourth minus 0 square. Okay, and you see that this guy, you not have y, so it's going to be just limit x go to 0. And this guy will be x to the fourth over x to the fourth. So it's going to be limit x go to 0 and x to the fourth over x to the fourth. We cancel them, so it's going to be 1. Okay, so it's going to be 1. So this limit turned out to be equal to 1. Okay, so now to be equal to 1. And for the second one, we're gonna try on y-axis. Okay, so for on the y-axis, you have x equal to 0. So for x equal to 0, this guy will become limit, let's try x equal to 0. So it's going to be 0 to the fourth plus y square over 0 to the fourth minus y square. And this one, you have no x left, so it's going to be limit y go to 0. So it's going to be limit, okay, and you're gonna have this one is going to be y square over minus y square, and this one will become limit y go to 0, and y square over y square is -1, so it's going to be -1. Okay, so you see that you have limit on C1 equal to 1 and limit on C2 equal to -1, and they are different. Okay, so they are different. So we're gonna conclude that the limit that you have here, okay, so the limit that you have here does not exist. Okay, so you have this limit does not exist in this case. Okay, so this one is number 2. For number 3, okay, for number 3, you have limit xy go to 0, 0, okay, of x squared y over x to the 4th plus y squared. So again, you're gonna try to find C1 and C2. So we're gonna try to find the limit on C1 and on C2. Let's try on x-axis again. Okay, so for if you have on the x-axis, it means you have y equal to 0. Okay, so you're gonna get limit and you plug in y equal to 0. So it's gonna be x squared times 0, x to the 4th plus 0 square. And like we did earlier, you see that the circle thing that I circle here turned out to be 0 over x to the 4th, and this guy become equal to 0. Okay, so this guy become equal to 0. So let me write it here, 0 over x to the 4th. So this guy turned out to be equal to 0. So this one turned out to be limit, okay? And you see you have no y, so it's going to be limit x go to 0, limit x go to 0 of 0, okay? So it's going to be 0. So this guy is equal to 0. Okay, so you have this limit. Again, okay, let's try another one. So for another guy, let's try on the y-axis. Okay, so on the y-axis, you're gonna do that. You have x equal to 0. Okay, so you have x equal to 0. So this one will become limit y go to 0, limit when x go to 0. So you get 0 squared times y over 0 to the 4th plus y squared. Okay, and you're gonna have y go to 0. And you see the same thing happen here for this term. Is 0 squared times y plus 0 to the 4th plus y squared. This guy will become 0 over y squared, and it's turned out to be equal to 0. So this guy will be limit y go to 0, okay? And this guy turned out to be, okay? So this guy turned out to be 0. So it will be equal to 0. Okay, so you have this limit equal to 0. So the thing that we have is the green, the limit on the x-axis turned out to be equal to 0. And the yellow one, the limit on the y-axis also turned out to be 0. So they are equal, they are not different, okay? And the thing that we need two directions that have different limit. So we not get the conclusion yet. Okay, so we not reach the conclusion yet because we still not be able to conclude anything due to we still have the same limit. So the thing that we're gonna do is gonna be we're gonna try to find another curve C3 in the case that we should hope for different limit from 0. So we're gonna just try to find another curve that the limit that we hope turn out to be not equal to 0. So the thing that I will use will be, you have to take a look that you see that if we have the top or the bottom and we need the limit different from 0, the thing that we gonna have to be able to do is gonna be, we gonna have to be able to combine. Okay, I would gonna say that we have to try to combine this term. Okay, what does it mean that I say try to combine this term? So you see that x squared, x to the fourth plus y squared. The thing that we try to combine this term is mean that you need y squared equal to x to the fourth. If you have y squared equal to x to the fourth, you'll be able to combine the term, right? You'll be able to combine the term. So if you have y squared equal to x to the fourth, the bottom guy turn out to be x to the fourth, and you'll be able to combine the term. Okay, so y squared turn out to be x to the fourth, okay? And you're gonna have y equal to, so in order to have y, you just take the square root both sides. So you're gonna get y equal to x squared. Okay, so you just have y equal to x squared. And this will be the place that you're gonna put for your y. So it's gonna be x squared and y equal to x squared. Okay, so this one will be just this guy. So it means that you need this guy on y equal to x squared. Okay, so this one will be the pink curve that we are having right now. Okay, so it's going to be, you need to combine the bottom guy. So you have x to the fourth plus y squared. So you try to combine this term. So you have y squared equal to x to the fourth. So you reach y equal to x squared. And then you see that this limit turned out to be limit x go to 0, okay, of x squared times x squared over x to the fourth plus x to the fourth. And this one will be limit x go to 0 and x squared times x squared turn out to be x to the fourth. And on the bottom, it's going to be x to the fourth plus x to the fourth. So it's going to be 2x to the fourth. And this limit will become 1/2. Okay, so the limit will become 1/2. And the pink limit will be different from 0. Okay, so the pink limit turn out to be different from 0, and you're gonna be able to reach the conclusion that you have the limit x go to 0, 0 of x squared y over x to the fourth plus y squared turn out to be does not exist. Okay, so we gonna just say that the limit, okay, so this is the thing that we looking for. Okay, so this limit does not exist. Okay, so we have the limit does not exist in this case. Okay. Okay, so I'm gonna make this one a little bit smaller. Okay, so this is the conclusion because these two guys are different. Okay, so you'll be able to reach the conclusion that this guy, the limit does not exist. Okay, I will give you one more example on this. Okay, so let me write you another example. The thing that I like you to show me is going to be show that this guy limit xy go to 0, 0 of x to the fourth y square over x square plus y square to the third does not exist. Okay, so you're gonna have to find C1 and C2 like we did in the previous example, and please show that the limit on C1 not equal to the limit on C2, and you're gonna be able to reach the conclusion that the limit xy go to 0, 0 of x to the fourth y square over x square y square to the third does not exist. Okay, so this one will be the thing that I like you to do. Okay, for number 4 as well. Okay, so for number 4, you like to show that the limit xy go to 0, 0 of sine x square over x square plus y square also does not exist. So please do this one, okay, by finding C1 and C2 that you have different limit. Okay, so it's going to be the thing that you see quite easy. Let's conclude this thing a little bit. So if you like to show that limit x go to 0, 0 does not exist, okay, so if we wish to show that limit x, y go to 0, 0 of f x, y does not exist, we may choose C1 and C2 as follow. So we may choose C1 and C2 as follow. So you're gonna have XY. Okay, so you have X axis and Y axis. And you have your 0, 0 in the middle. Okay, so this is the origin. And you see that you can try, okay, you can try the x-axis, okay, you can try the y-axis, you can try the y-axis, okay, so you can try x-axis, y-axis, okay, so this one will be y equal to 0, this guy will be x equal to 0, or you may try x equal to y, x equal to y. So this one will be x equal to y, or y equal to x, or another line will be x equal to negative y, x equal to negative y. Okay, so this one is x equal to negative y. Let me make it into straight line. So this one is x equal to negative y, okay? Or maybe you can use the parabola, y equal to x squared. Y equal to x squared is the parabola like this. Y equal to x squared, okay? Or maybe you have the S-shaped curve, y equal to root x, y equal to root x, look like this one, y equal to square root x, okay? So that will be the graph that gonna pass to the origin, okay? So the thing that this graph have in common turn out to be this graph passes through the origin, okay? So it's passed to the origin in the middle here, okay? So you can just pick C1, C2, C3, or maybe you can use other thing. And the trick that I taught you here is going to be, you should try to combine the power on the bottom. The way that to get to combine the power turn out to be you're gonna need this term and this term turn out to be the same, okay? So it's gonna give you the condition that allows you to combine the term. Okay, so that will be the thing that I left you, okay? I left you these two examples for you to work on your own. Last thing for this script is going to be about continuity. When you have a nice surface like we have seen in the first page, so you see that the surface turned out to be without any hole at all. So you see that the surface turned out to be nice, turned out to be without any hole, without any jump in this case. So this one turned out to be the surface that we're gonna call is gonna be continuous. Okay, so we have the surface turned out to be continuous. And the meaning for continuity into variable is exactly the same as the meaning for continuity in one variable. It means that the limit x is equal to the value of the function at x0, y0. Okay, so the continuous mean that we have limit xy go to x0, y0 of fxy turn out to be equal to fx0, y0. Okay, so we like to find the constant c such that the function f is continuous at x0 at 0, 0. Okay, so we need c to be just the limit xy go to 0, 0 of r10 x squared plus y squared over x squared plus y squared. Okay, so we need c to be like this, okay, to be this limit. And the thing that we're gonna do is gonna be, we're gonna approach 0, 0. So let me also draw a picture a little bit. So you see that if you have a circle radius r, so if you have circle radius r, so you have the circle at center at the origin of radius r. This one you have 0, and this one you have the radius r. And if you make this circle smaller, okay, so if you make this circle become smaller, let's make this guy a little bit smaller again. Okay, so you see that if you approach this point 0, 0, okay, so if you are approaching this one and you see that if you take r go to 0, okay, so if you take r go to 0, you're gonna reach this guy, okay, and this guy has equation x squared plus y squared equal to r squared, okay, so this guy has equation x squared plus y squared, x squared plus y squared equal to r squared. Okay, so this guy has equation x squared plus y squared equal to r squared. Let me erase this one a little bit. Ah. So you see that the origin in the middle, okay, so the origin in the middle turned out to be 0, 0, in 0. So for this one, you like to approach 0, 0 in the middle guy, okay, by just changing x squared plus y squared, and you let it equal to r squared. So you see that x squared plus y squared, you have two places here, okay? So you would just have limit, okay? So you change x squared plus y squared into r squared, and it's gonna be over r squared. And when you have xy approaches 0, it means you're gonna have r also approach 0. Okay, so this one is going to be just I change two variable into one variable, and we'll be able to do something like this because you are approaching 0, 0 in the direction of you gonna like have the smaller circle. So it's gonna be smaller, 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 and it's gonna approach 0 in those directions. So it's gonna be like the squeeze the pulp of the fruit down to the point 0, 0. Okay. And you see that this limit turned out to be the same, and we gonna be able to compute this limit by this one is gonna become 0 over 0 and use L'Hopital. So you'll be able to just find derivative of arctan r square. Okay, so you div. So it's going to be limit r go to 0. Dip arctan r square is going to be 1 plus r square square times 2r. And dip r square is 2r. Okay, so that is going to be 2r and 2r that we shall get rid them off. Okay, so that is going to be cancelled. So you get 1 over r to the fourth. So it's going to be 1 over 1 plus 0 to the fourth. So it's going to be equal to 1. Okay, so we're going to have c equal to 1 in order for the function f will continue as at 0, 0. Okay, so this is how we find this limit. Okay, so I will stop here for this script. The thing that we be able to do right now is going to be we be able to show that the limit of the function at 0, 0 or does not exist. Okay, so that is going to be the crucial thing for this clip, and we be able to compute the limit by using the smaller circle, like in this example that we change the variable x squared plus y squared to become r squared, and we change from two variable to one variable, and we allow to use L'Hopital in order to solve for limit. Okay, so try to do exercise 14.1, 14.2. The thing that you are studying right now turn out to be similar to calculus 1. Okay, so in this two video, we already study how to find the limit. The next one that we're gonna study is gonna be, we're gonna begin differentiate the function. So it's gonna be the thing that called partial derivative. Okay, so I'm gonna stop here.